Hey everyone, Mr. Fransky here. Today we're just going to be going over the solutions to the blue sheet that you guys have. I use blue for blue sheet. It's just about vector navigation problems. So remember, this is just basically where we're taking components and adding them together. You're going to one for each one of these, going to make an X, Y list. For your two vectors, maybe they're V and W. Right? Then you get your atom component-wise to get your resultant vector, and then you might have to be able to find the direction and final velocity or whatever it is that they're asking for, final magnitude for the vector for each problem. So the way I would use this video, I would try the sheet. The solutions are online. And if you struggle with the problem and don't understand the solution, come back here, watch the video, see what I did that didn't make sense to you before, and hopefully that's going to make a little bit more sense. So let's jump in and give this a try. So the first problem is just kind of a basic intro problem here. They give you two vectors, they give you the magnitude and also the direction, and they want you to find r plus s. So first they want you to find it in component form. So what I'm going to do here is just make an x and a y list for each of these. So we have r and we have s. And then we're going to have our result underneath. This will be r plus s. Okay, so we're going to break these down into the components. So vector r has a length of 16 at 60 degrees. That's going to be something like this. So this is 16 and this is 60 degrees. So I'm going to break that up into its components. Remember, we can just use r cosine theta and r sine theta. So, magnitude cosine theta and magnitude sine theta. This is going to be 16 sine theta right here, 60 degrees. This guy down here is going to be 16 cosine of 16 degrees. So cosine of 60 degrees is 60, not 16. Cosine of 60 degrees is 1/2, so this is going to be 8. Sine of 60 degrees is root 3 over 2, so this is going to be 8 root 3. And if you put that into decimal form, that gives you 8 and 13.85. So just grab your calculator and type that in. 16 sine 60, it'll give you 13.85. Then for s, vector s looks like it's 35 at 100 degrees. That's going to be over here, 10 degrees past there. So this is 35, and the whole thing is 100 degrees. So I can do 35 cosine of 100 and 35 sine of 100, right? So this guy down here is going to be 35 sine 100. This guy over here is going to be 35 cosine of 100. Grab a calculator, punch those in. That gives us negative 6.07. Makes sense that the x is negative and our y is 34.46, I believe. Then you just add these together in columns because you can just add the components to vectors. So 8 minus 6.07 gives you about 1.93. I think in the solutions I had 1.92 because I didn't round. And then the y, if you add them together, gives you 48.32. Okay, so that is the components of our new vector. That's what they ask for, is just the resultant vector in component form. So there we go. Now they want the magnitude and direction. So if I'm at 1.93, that's barely out, it's mostly up, right? So 48.32 is my y. 0.32. And, oops. And my x over here is just very small, 1.93. So magnitude of r plus s going to be square root of 48.32 squared plus 1.93 squared. Okay. So grab a calculator, crunch that out. Looks like it is 48.362. Makes sense that it's really close to the y coordinate because the y coordinate is what's making up most of this vector. And then if I want this little theta right here, tan of theta is going to be the 48.32 divided by 1.93. So if I want theta, it's going to be tangent inverse of this guy right here. And type that in your calculator, and you get an angle of 87.72 degrees. Oh, come on. And that is the actual standard angle from standard position, but I could also write north of east. So in all these problems, I'm going to actually write out, the direction that it's going, because I just think that that's useful to be able to see. Okay, so we have 87.72 degrees north of east. So we have our magnitude, we have our direction, that's what they asked for. All right, let's try the next one. You can swim at 3 kilometers per hour, and you're swimming straight east in a stream with a current of 5 miles per hour. So we got a 5 miles per hour throwing south, and you are swimming at 3 kilometers per hour to the east. Okay, so let's make an XY chart here. So we have U swimming, and we have the current. Okay, so you are swimming 3 straight east, so that is only an x component, 3, 0. And the current is going 5 kilometers south, so that would be 0, -5. If we add those together, their resultant vector is going to have components 3, -5. Find your actual velocity and direction. So we got you going 3. We got the current going south at 5. Looks like you're going to be heading southeast a little bit, right? This is our resultant vector. Let's call it R for result. Okay. This is our R. So we know that that has components 3, 5, which we can see right here. So we want the magnitude of R, which is going to be your velocity, how fast you're actually going. It's going to be the square root of 3 squared, which is 9, plus 5 squared, which is 25. Gives you the square root of 34. Square root of 34 is, oh, I didn't write that down. I don't have that in my calculator. So root 34, I think is the best we're going to do there. Okay, so that's how fast you're going actually. And the direction, so for theta, so if I think about this like this, so I want theta maybe right here. So tan theta is 5/3. Could do -5/3, you want to get this right, but theta is going to be tan inverse. Oh my goodness. Stop doing that. So theta is going to be tan inverse of 5/3. Which is, why does that keep happening? Tan inverse of 5/3 is 59 degrees. Okay, and that is going to be south of east. So you don't have to worry about positives and negatives. I could subtract from 360 if I wanted the actual angle, but that's going to work just fine. Okay. So we have our speed, we have our direction. Now they say, if the stream is 1 kilometer wide, how far downstream will you come ashore on the other side? So the question here is, how long does it take you to cross the stream? So if the stream is 1 kilometer wide, and you swim at 3 kilometers per hour, it should take 1/3 of an hour. I think this is, you can think about this conceptually, right? It's going to take 20 minutes to cross the stream. Okay, so 20 minutes to cross the stream. But if you actually want to do this analytically, so if you take 20 minutes to cross the stream and it's flowing south at 5 miles per hour, then you can just think, well, it's going to move you just as far south as if you've been sitting still, right? Because you only have an x component. You're not helping or hurting the current at all. The current's just going to carry you down however long you're sitting in the stream. But I think the better way to do this is to say, well, you've got 1 kilometer to go, and you can swim 3 kilometers in 1 hour. So that's what gives you the 1/3 of an hour, right? Because the kilometers cancel. So that tells you it takes 1/3 of an hour to be able to cross the stream. And then we know that the current is moving at 5 kilometers per hour. So then the hours cancel, and you end up going 5/3 of a kilometer. So in the 20 minutes it takes for you to go across the stream, I thought I fixed this. I don't know why this keeps happening. So the 20 minutes it takes you to cross the stream, the current will move you down 5/3 kilometers. Cool. Alright, a ship sailing through the water in the English Channel with a velocity of 22 knots along a bearing of 67 degrees south of east. 67 degrees, something like that. 67 degrees south of east, and it's going at 22 knots. Okay. And the current has a velocity of 5 knots and a bearing of 33 degrees west of south. So this is the ship. Current, 5 knots along a bearing, 33 degrees west of south. So something like this. Here's our 33 because it's west of south, and it tells us that current is 5. Now, I don't love this 33 because it's not cozied up to the x-axis. So I'm going to subtract from 90 to get 57 right there. You'll notice I did some of these a little bit different on the solutions I have online, but that's okay. It doesn't matter how you do it, as long as you get the right answer. So you have 67 cozied up to this x-axis, 57 cozied up to this x-axis to make an x and a y chart. So we have the ship, and we have the current. So the ship, if we do 22 cosine of 67, 22 cosine of 67 will give me the x. So 22 cosine of 67 gives me 8.59. Makes sense. The y should be taking care of most of that because it's a pretty steep angle. And then the y, if you do 22 sine of 67, you get positive 20.25. But it's going downward, so I want that to be negative. So you should make it negative 20.25. If you had found the actual angle all the way around, you could have just done it, and it would have given you the positive x value and a negative y. But I just like to use my brain, right? You just find that magnitude, and we know it's negative. For the current, so the way I did this on the worksheet is I said, well, if you split the current into its components, the y-coordinate right here is adjacent to the angle of 33 degrees. So I actually used cosine to find the y and sine to find the x. But since I changed it to 57 and it's now next to the x-axis, I can just use sine and cosine how I want. So if I do, for the y component right here, if I do 57 sine, 57, 5. Go back. Okay. So we're going to do 5 sine of 57. And here we're going to do 5 cosine of 57 to find those coordinates, because really we're doing this component up here, right? It's adjacent. So if you do 5 cosine of 57, that'll give you the x coordinate, gives you negative 2.72. Thought it was too small for a second there, but we're only dealing with a 5, not current. And then the y, if I do 5 sine of 57, I get negative 4.19. Makes sense, they're both negative because it's in the third quadrant. So I would actually get positive values for both of those, but then I make them negative because it's in the third quadrant. So let's find our resultant components then. Add these together. You get 5.87. So you're still going to the right, you're still going to east. And then negative 4.19. Nope, negative 24.44, sorry. I'm looking at the wrong product. Negative 24.44. There we go. So we got our components, and now what they want us to do is find the actual velocity and direction. So positive, negative, so we're in the fourth quadrant somewhere. 5 is pretty small, negative 44, it's going to be like down, something like that, 24. So this is 24.44. This guy right here is 5.87. Okay. So they want magnitude and direction. So the magnitude of our resultant is going to be the square root of 5.87 squared plus, come on, 24.44 squared. And that gives us a velocity of 25.14. Knots, I guess. And then for our direction, let's put theta right here. So tan theta is going to be 24.44 divided by 5.87. So theta will be tan inverse of that guy. And plug that in your calculator, you get 76.49 degrees, and that would be south of east. And there we go. Oh, jumped ahead a little bit there. But yeah, that's all there's to it. So making this XY list and finding magnitude and direction, that's really the key to be able to do these. All right, next up we got a speedboat. Traveling on the mid-Hudson Bay, encounters a current of 25 miles per hour at 2 degrees north of west and a headwind of 32 miles per hour at 16 degrees south of west. The boat's speed is 107 miles per hour at 60 degrees east of north. What is the boat's resultant speed and bearing? So we've got 3 vectors going on here. This is why I think it's important to make these lists, right? We have the boat, we have the current, and we have the wind. Okay. So the boat is heading at 170 miles per hour, 60 degrees east of north. So 60 degrees east of north looks something like this, 60 degrees. And they tell us it's going at 107. Pretty fast boat. Okay, so if I want to break this into its components, I'm going to change this to have a 30-degree angle down here. Could use 60 and use sine and cosine opposite the way we want, but if we have that angle cozied up to the x-axis, then we're going to be able to use just sine and cosine like we want. So our y-coordinate here is going to be 107 sine of 30. Sine of 30 is half, so half of 107, that is 53.5. So we have 53.5 for the y. And then x, so we're going to have 107 cosine of 30. Go to a calculator for that because 107 times root 3 over 2. I'm not really sure what that would be. Looks like that would be 92.66. Again, that was 107 cosine of 30. All right, the current, it says, is 25 miles per hour, 2 degrees north of west. That's pretty much going backwards. 2 degrees. So 2 is cozied up to the x-axis, which is what we need it to be. And it's going 25 miles per hour. So this will be 25 sine 2. Going to be very small. This guy over here will be 25 cosine 2, which can be real close to cosine. Or 25, excuse me. So 25 cosine of 2 is 24.98. I need to make it negative. So we have negative 24.98. Negative because it's going to the left. And then our y, 25 sine of 2, very small. It's 0.872. We also have some wind here. So this was the boat. This is the current, and this is the wind. Okay, so for the wind, we have the wind going 32 miles per hour, 16 degrees south of west. So it's like this. So this is 16 degrees right here, which is against the x-axis, so we want. And we know that that velocity is 32. So this guy right here, going to be 32 sine 16. This guy right here is going to be 32 cosine of 16. Punch that in. Sine of 16 and cosine of 16, I don't know what those are. They're weird numbers. But if you plug those in your calculator, 32 sine of 16 gives you 8.82, and it's down, so it's negative 8.82 for the y. And then for the x, we have 32 cosine of 16, also going to be negative. Looks like that is negative 30.76. So now if I components, we just add these three. It's all you have to do. You get components of your vector at 36.91 and 45.55. Okay. So notice it slowed down quite a bit because it's trying to sail east, and both the wind and the current are pushing it west. They want resulting speed and bearing. So the speed of this thing, square root 36.91 squared plus 45.55 squared. Throw that into your calculator. Should give you a speed of 58.63. So like half of its speed that it was before, close to it. And for the bearing, so if we're positive here, we're still going into the first quadrant. So we have 36 and 45, so a little bit more up than out. So this is 45, this is the 36. This is theta. So I'm going to do tan theta is going to be y over x, so it's 45.55 divided by 36.91. So theta will be tan inverse of that guy, and that ends up being 50.9 degrees. And that's definitely going to be north of east. Okay, so it's north of east. Good. Jumped ahead again. Okay. So, use tangent to find that angle. Just use Pythagorean theorem to be able to find the magnitude of the speed. Alright, moving on. Airplane is flying at 450 kilometers per hour, 20 degrees south of east, when it encounters a powerful wind from its right side at the tail. If the resulting velocity is 4 degrees north of east at 520 kilometers per hour, what is the speed and direction of the wind? So this time I know the resultant. I don't know the speed and direction of the wind. So we have the plane. Here's our x and our y. And we have the wind. And we have the results. Okay. So plane is flying 420, 20 degrees south of east. So south of east looks something like this. That's 20 degrees. Cozy up to the x-axis. Perfect. Okay. This is 450. So we're going to have 450 sine 20 and 450 cosine 20. So 450 sine 20, so that's going to be the y-coordinate of the plane. Yeah. Am I reading the right problem? I hope so. Yes. Sorry. 450 sine of 20. 450 sine of 20 is 153.9. And of course it's down, so I'm going to have to make a negative. So I have negative 153.9. The x 450 cosine of 20 gives me 422.86. Right? Much more right than down. Okay. So we know the result. The resulting is 4 degrees north of east at 521. Okay, so this wind must be pushing pretty hard from the backside right tail because it's going to be pushing it all the way to be up this direction, going up. Okay. I say 512, this should be 521. There we go. Okay, so let's break that into its components. We'll have 521, keep wanting to do 512. 521 cosine 4 and 521 sine 4. Okay, 521 cosine 4 should be real close to 521. Gives me 519.73. Remember, this is the resultant. And then the y, 521 sine 4, should be pretty small. It's 36.34. So the question is, what's the result? Well, I can find these two things, right? I can find these two things by subtracting. Because when I add these together, it should make 519. So to find this guy right here, it's going to be 519 minus 422.86. And 519 minus 422.86 looks like that gives me 96.86. So that's going to be my x, so 96.86. And then for the y, it'll be 36.34, technically minus a negative. I'm going to write that as a positive, 153.9. And that gives me 190.25. Okay, so we have our resultant vector, or our wind vector, and they want to know the speed and direction. So those are both in the first quadrant. So a real strong wind going more north than it is east. So we'll have the square root of 96.86 squared plus 190.25 squared. And that gives me a speed of 213.49. We have our components, right? Our components are, I should circle that. 213.49. And then our components here and here are 96.86 and 190.25. So tan of theta, which I'll put down here. Tan of theta is going to be y over x, which is just 190.25 divided by 96.86. So theta is going to be tan inverse of that guy. I get 63.01 degrees. That would be north of east. Cool. So we got our magnitude, got our direction of our resultant vector. Or our wind vector, excuse me. The resultant we know. So now they tell me a boat wants to cross a river that is flowing north at a speed of 2 miles per hour. So we got this river flowing north, 2 miles per hour. Boat is capable of sailing at 12 miles per hour. If the captain wants to sail directly across the river, what direction should he sail? So he wants the resultant vector to be straight across. And if we have the river flowing north, the captain must finish that triangle, have the same y component that's going to cancel out the y, and the x will have to be such that we end up going straight east. Okay, so north 2, and the boat can go at 12. Alright, so let's make a little chart here. So we have our x, we have our y, we have the boat, we have the current. Okay, so the current is at 0, 2. The boat I don't know. Right? The y, though, definitely has to be negative 2 because these have to cancel out. My resultant has to end up with 0 for the y component because he wants to sail straight east. So I don't know what this is. Okay. But I know this is negative 2 because it has to cancel out the y. So that's 2 and this is 12. There are all kinds of things we can do. We got theta here. So I want to find theta. It looks like I could use sine. So sine theta is 2 over 12. So then theta is sine inverse of 2 over 12. And that gives us 9.59 degrees. Okay. And that is going to be, it looks like, north of east? No, lies. I did this wrong. Shoot. It's okay. Not a big deal. So I want the resultant to be straight east, but if I add the vectors, it has to be like this, right? Because I need the y component of this guy to cancel out the x component of the other guy. So we got to be going downwards. So that has a component of 2, and then the y component, I don't know yet, or the x component, excuse me. But that's 9.59 degrees south of east. Yep. So if we're going 9.59 degrees south of east, I can now kind of think about that triangle. Let me draw it again. This is 2, this is 12, and this is 9.59 degrees. Maybe I can use cosine, right? Cosine of 9.59 degrees, I want to know what this x is. Because that's going to tell me what the speed is going to be that it's actually traveling. That's my resultant. So I'm going to do cosine 9.59 is equal to adjacent, which is x, over hypotenuse, which is 12, multiplied by 12. And that gives me 11.83 miles per hour. Cool. Keeps jumping ahead, but right after I finish the problem. Okay. So, notice they give you different parts at different times. I just found that's 11.83 for the boat. Which is then how fast it'll actually be going. Come on. There we go. Because the x component is the only thing that's controlling how fast it's going from side to side. Nice. Alright, moving on, since apparently PowerPoint wants me to keep going. If a plane is capable of flying 530 miles per hour, and it wishes to fly straight north into a wind blowing at 42 miles per hour, 13 degrees west of south, what angle should the plane fly? So the plane wants to fly straight north. That's my result. Okay, we have this wind that's blowing at 42 miles per hour, 13 degrees west of south. So west of south is going to be like over there. So we have the wind blowing something like this. Okay, so when I add them, I should do tip to tail. So the plane, it looks like, is going to have to fly, if the wind is going southwest, the plane's going to have to fly a little bit east in addition to north in order to counteract that wind. We're going to have to cancel out the x component of the wind, so it's flying straight north. So let's make a chart. So we got x and y of the wind and the plane. Okay. So we have to figure out the components of the wind. We have a result here. We know we want our result to be straight up, so it's going to have no x component. So we got to break the wind into its components. So we know that it's at 13 degrees west of south. So this is 13. I don't like that because it's not cozied up to the x-axis, so I'm going to subtract from 90. This is going to be 77. Okay, so now I can break it up into its components. The y is going to be 42 cosine 77. Right? That's going to be the x, excuse me. And the y is going to be 42 sine of 77. So 42 cosine of 77 tells me that the wind is going downward at negative 9.44. Right, I added the negative because it's going down. And the y should also, going left. And then the y should also be going down, should be negative. 42 sine of 77 gives me negative 40.92. So the resultant vector has to have no x component. That means the plane must be going to the right, or to the east at 9.44. Whoops. And we'll figure out how fast it's going in a second, right? So we have the wind going like this. The plane must counteract that, right? So it's going to be, I want to think about how I want to do this. The plane will have to be flying east. I want it to look something like, let me think about it, like this. Okay, so this is my plane. And the resultant vector is going to be straight north. That's the goal. So, if we know that the plane is flying at 9.44 to the right, so this is our plane vector, this is 9.44, and we know that the speed is 530, then I can find the angle theta right here. So I guess I would use cosine, so cosine of theta, going to be adjacent over hypotenuse, that's 9.44 divided by 530. So theta will be cosine inverse of that guy. Throw a cosine inverse at that, you get 88.97 degrees. Theta, 88.97 degrees north of east. Oh, don't do that to me. Keep them. Bring me back. Okay. And then for, so that gives us our direction. That's where the plyout should be flying. Back to red. That's just fine. And then we want to know how fast it's actually flying north. Okay, so we want to know the resultant of our plane and the wind together. So in this case, we're going to use sine, I think, to find this. So if we want to know our vertical component here. So we're going to do a sine of 88.97. Going to be equal to opposite over hypotenuse, which is, oh my goodness gracious. X, no, stop that. Oh my goodness. Sorry. Let's keep using red. Okay, so sine of 88 is going to be x over 530. Multiply by 530. And you get an x. Oh, stop. I thought I fixed this. Apparently not. Okay, so if you multiply by 530, that's going to give you, I guess I should have used y because it's really the vertical component. That gives you a y component of 529.91. 521.91 there. So that is the plane's vertical component. And then if we want to actually find how fast it's actually flying north, I think this problem is actually wrong in the solutions. So I'm going to grab my calculator and figure this out. Because I think that I answered with 521.91 in the solutions, which is actually the vertical component of the plane. But then the wind is counteracting that. So we have to figure out what the actual vertical result is. So if I'm going to do negative 40.92 and subtract from that, or add to that, excuse me, 521.91, that gives me 480.99. And that is how fast the plane is going north. Wow. One more time. Okay, so 480.99 miles per hour is how fast the plane is flying north. And that is just driving me nuts. Okay. All right. So hopefully this was helpful. If you have any more questions, you can look at the solutions online. That last one I think was not quite entirely correct, but that should be the correct resultant, that 480.99. Love you guys. That's why I'm here. Have a great day.